Alright, people, trig identities day 1. Alright, so some of these are more important than the others. So some things you already know. Cosecant is 1 over sine. Secant's 1 over cos. And cotan's 1 over tan. And it goes the opposite there. If we have sine, that is 1 over cosecant. If we have cos, that's 1 over secant. If we have tan, that's 1 over cotan. As we're working on this identity worksheet, it's going to be key to know this because more often than not, we want to make sure that we have less trig functions. If we are able to take something from having 4 different types of function down to maybe 2, it'll make life a little bit easier. And right now, it doesn't make much sense, but as we get into the work, that'll be a little bit clearer. Alright, so essential section. Quotient rule. Essential section. So we know that tan is sine theta over cos theta. We know that cotan is cos theta over sine theta. Alright, so those are 2 very important rules that, again, will help make our life a little bit easier as we go through this. This section, not the end-all be-all of what we've been doing. But the idea is that with sine, right? So we know that sine, if we had a capital, sine's between negative 90 and 90. So if we were to think about a negative angle for sine down there, based on ASTC, right, the reference angle idea, it would be a negative sine. Right? But cos, we know when we talk about the capital C, we're going from 0 to 180. Right? So if we're talking about ASTC, looking up here again, right, down there in that 4th quadrant, that negative angle, we're getting a positive cos. Right? Down the 4th quadrant, we're getting a negative tan. So the idea with the reference angle will be a negative tan. So this is touching on something we talked about previously, but I don't want to really focus on this. It's not a main idea of what we're covering right now, but I know people always like filling out all the boxes, so this goes back to the reference angle problems from a while ago, right? And touching on that and moving on from that. Another section that's not overly important to what we're doing is cofunction relationships. So what this is saying is that sine theta will always equal 90 cos 90 minus theta. And if we think about it, sine theta, where's that? If I had sine of 30, right, sine of 30 is 1/2. Well, cos of 60 is also 1/2. Right, so there's that setup. Sine 30 is the same thing as cos 90 minus theta. All right, so if we had cos is the same thing as sine 90 minus theta. All right, if we look at tan, right, tan works with itself, right, because tan doesn't have the flip-floppiness of the unit circle like we have with cos and sine. All right, so tan would be cotan 90 minus theta, while cotan would be tan 90 minus theta. And again, if we had tan 30 is the exact same thing as cotan of 60. All right, so tan 30 we're looking at rad 3 over 3. Well, cotan 60 is also rad 3 over 3. All right, so again, not a major thing, so I'm not fully focusing on this right now. But I want to fill in the boxes to make sure we have them all. All right, so going back, those 2 sections are definitely more important than these other 2 sections right now. And this is the major one, right? This is the major one that makes all the sense with what we're doing. All right, so what we have with a unit circle, to explain these rules right here, what we have, if we look at a unit circle, and we have a point, so make my circle x comma y. Right, so if we're looking at unit circle, we all know that r is 1. So our perfect Pythagorean theorem setup is x squared plus y squared equals 1 squared. So x squared plus y squared equals 1. What we also know is that x is cos and y is sine. So we can write this as cos squared x plus sine squared x equals 1. So that's why our first big identity rule, sine squared theta plus cos squared theta equals 1. And that's because we have Pythagorean theorem on our unit circle. Our radius is 1, and x goes with cos and y goes with sine. Okay, if I were to balance things out and divide everything by cos squared theta, that would give me 1 plus tan squared x equals 1 over cos is secant squared x. Alright, so we took the original, divided it all by cos, and that gave us our new setup. So it's not that this is a different formula, it's a variation of the original formula. And everything we're looking at right now is coming from this. So if we want to make another formula, imagine we took a moment, cos squared x plus sine squared x equals 1. Imagine I divide everything by sine squared. Alright, so cos over sine is cotan squared x. Sine divided by sine is 1. 1 over sine is cosecant squared x. Alright, so there's a third formula setup. Now, even within these, we have a few other setups. So like over here, we could have cos squared x equals 1 minus sine squared x. Sine squared x equals 1 minus cos squared x. So those would be variations off of that original setup. Right? If I were to rearrange stuff here, 1 equals secant squared x minus tan squared x. Right, maybe I got tan squared x equals secant squared x minus 1. So again, these aren't terribly different, they're just moving things around that have a different look. Right, so what do I got here? 1 equals cosecant squared x minus cotan squared x. Then I could have cotan squared x equals cosecant squared x minus 1. Right, so really, looking up there, we have 9 different things, but it all comes from this. This is the one. Sine squared x plus cos squared x equals 1. Everything works off of that. And that's the one we have to know, and that's the one we have to modify. So one of the most common mistakes is people will sit there and try and memorize all 9 of these different setups. Really, you could just work them out. Right, so as long as you know sine squared x plus cos squared x equals 1, you could work off of that and get all the different setups. Alright, so 2 different types of problems we're going to have is problems where we're asked to simplify and problems where we're asked to prove. So a simplified problem means we want to take this and make this, as shrunken down as possible. So if I'm looking at this one, I got 3 different trig functions. I got sine, secant, and cotan. And one of the things earlier I said is if we could take it and shrink it and have less options. So right now there's 3 different functions. I want to make this have less functions. Well, sine I'm going to leave. Secant is 1 over cos. And cotan is cos over sine. So by doing this, I now have only 2 different trig functions. Alright, so I had 3 before, now I have 2. Alright, what can I do here? Cancel the coses, cancel the sines, I am left with 1. Alright, so what we want to do in a problem like this is we want to simplify it down and get it as small as possible. And the key strategy I stick with is I try and make things cos and sine. That's one of the general ideas I go with. If I can make things cosine sine, it tends to work better. All right, so that's what I did there. Sine, secant, cotan, made them all into sines and coses, and I was able to cancel things out. All right, that was a baby one. All right, getting a little bit more complicated. So going off the idea from before, I can write this as 1 over cos minus sine times sine over cos. All right, so before I had 3 different functions. Now I only have 2. Well, I can combine cos theta minus sine squared theta over cos theta. Lucky me, in this scenario here, by working it out this way, I have my common denominator. So since I have my common denominator just given to me, I can combine this. All right, so I took it from 2 separate pieces into 1. All right, what can I do now? This is where we bring in the identity. This is the main identity we have. This right here is a variation of it. So if I manipulate this around, 1 minus sine squared x equals cos squared x. So with my work here, I can simplify this to that, which gives me just cos x. All right, so we're always looking to find ways to change things up to benefit us. All right, so my first method I was going with is trying to make things into sine and cos. From there, we look for those identities. Right? Everything stems from this, but as we talked about earlier, there's 9 different variations within that. And trying to figure out which one could help us is always the best way to go about doing this. All right, so what I'm thinking, I got 1 over sine times cos. I'm going to make tan into tan. We got sine over cos minus sine. All right, so if I distribute, well, I can work the inside for a second. 1 over sine x times, cancel the cos, made that cos squared. So I got cos squared x sine x. Now it's over 1 minus sine x over 1. So if I distribute cos squared x sine x over sine x minus sine x over sine x. Okay, so I can do some canceling. Gone, 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 gone. Cos squared x minus 1. Now we did a lot, we shrunk it down, but again, what can we do more, right? We got 2 pieces there. Is there anything we can do to make this even simpler? All right, so I know cos squared x plus sine squared x equals 1. All right, so if I do some manipulation, leave that, subtract the 1, subtract that over, there's my setup. Cos squared x minus 1 equals negative sine squared x. And that's what we have. Now here's the thing with these simplified problems. With the simplified problems, there's nowhere telling us where we're going to end. So we're kind of just working through, hoping we can see the next step and kind of hoping that we can get to a future ending spot. But the problems we're really working towards are these. And the benefits of these problems is they tell us to prove this. They tell us to make sense of this. Right? We want to end with cos squared x. I don't know why it's an A. Right? We want to end with that. That's what we're looking to get. The problems before was very kind of vague. These are pretty defined. Right? So the goal is we're only going to work with one side. Right? We work with one side only. Right? The other thing to consider is, looking for the complicated one to shrink it down. Right? Taking cosecant squared A and trying to expand it, a little bit tricky. So we're looking at the complicated side and we're working to shrink it down. All right, so looking at what I got here. right away I notice 1 plus tan squared a. So going back up to here, 1 plus tan squared a is secant squared. All right, so that'll help me out to get it going. So I'm changing this to x, I don't want to work in a. Secant squared x over tan x. All right, so I got that. So with this, I could kind of separate it out. I could write this as cotan x times secant squared x times 1 over tan. And one thing I want to make clear as I'm starting this problem off, there's multiple ways to do every problem, right? Just because I'm showing you one way doesn't mean it's the only correct way. You could figure out a totally different way that makes perfect sense and works out in the end. Whatever works for you is going to be fine for me as long as you show in the end this is cosecant squared. Okay, so I got, so I got this, and then one of the rules we talked about was maybe I make things into sine and cos. So if I go cos x sine x times 1 over cos squared x times 1 over tan x. All right, so I'm able to do some canceling there. Cancel, cancel. So now I got 1 over sine x cos x times 1 over tan. I'm going to work up here now. Well, no, if tan's in the denominator, I could bring it up. 1 over sine x cos x times cotan x. 1 over sine x cos x times cos over sine. That sets me up to cancel the coses. And then I have 1 over sine squared x, which equals cosecant squared. So this is one way to do it. And you could do it in more steps, you could do it in less steps. Whatever you're doing is going to work out. If you're doing the math correct, it's going to work out no matter what. Right, so this is one way to do it. You're looking there, you might have saw a different way to do it. Go ahead. Either or, fine with me. All right, so one big helpful thing is common denominator. A lot of these problems, if you get a common denominator, it's going to make the problem smoother, make the problem easier, and make things work together. So if I want a common denominator here, I got to multiply this side by 1 plus secant x over 1 plus secant x. And this, 1 minus secant x over 1 minus secant x. So I'd have 1 plus secant x over, if I FOIL it all together, 1 minus secant squared x plus 1 minus secant x, not squared, over 1 minus secant squared x. Okay, I got that. I actually add them together. When I add them together, I have 2 over 1 minus secant squared x. All right, our identities. All right, 1 minus secant squared x. 1 minus secant squared x. All right, we're kind of here. All right, so we got something in the ballpark of that. All right, so tan squared x equals secant squared x minus 1. All right, so tan squared x equals secant squared x minus 1. Which, if I maneuvered things around, would be 1 minus secant squared x equals negative tan squared x. So this gives me 2 over negative tan squared x. Now if tan's in the denominator, I could bring it up. Negative 2 cotan squared x. Done. So in the end, what are we doing? We're manipulating things. We're moving things around. We're not actually doing, we're just kind of, I guess it's almost what we're doing basically is like saying that like 2 over 2 is 4 over 4. They're the exact same thing. We're multiplying, we're adding, we're subtracting, we're moving things around, we're simplifying things to prove that in the end, the right side is true. It does equal negative 2 cotan squared x.